Well, hello and thank you for choosing this track, this slide. It's not very easy presenting in a multiple track convention. I hope you will enjoy this presentation. And what I'm going to talk about, I'm going to talk about the output of research I've been conducting in the past year of how to, a better technique of performing black box pen testing on iOS applications. So before we even start, let me start with a WTF disclaimer. For all of you who've never been into a black box iOS pen testing, we're going to cover some topics and run over them, such as Objective-C, class TAMZ, etc., that may be new to you, so don't hesitate. There's a specific slide for the web reference. You can educate yourself, or feel free to use the door and find a different talk. So, a little bit about myself. I'm a security researcher, trainer, and geek, you can call it. And I work for AppSec Labs Security as the chief scientist. Means they pay me for having fun, which is a really good deal. So, what else? The agenda for us today. We're going to start talking about what is the current black box typical setup that you're probably all aware of, or most of you are aware of. And then we're going to talk about problems with that setup. What problems we have with the current setup. We need some new tools or new innovation to help us perform a black box. And then we're going to represent iNalyzer. I hope we'll rush through the entire topic so we can have a live demo with the audience collaborations. Okay, so a bit about iOS apps and what are their vulnerabilities. So what is an iOS application? iOS application is eventually the end product of a predefined Objective-C or C++ source code file. This was compiled to a specific ARM binary format in ARM assembly. And usually a normal application that are downloaded by iTunes are installed in a specific location on the iDevice, on the iPad or the iPhone, with a specific username mobile. It should execute under Sandbox, but it's already documented that for each version and API, there are some kinds of holes that apps can sneak in between or bypass Apple policy into doing something that they shouldn't do. Okay, like SpyPhone and StormMate that was augmented. So about that, what are the current, or what are the total vulnerabilities that mobile application, iOS application can be attacked by? We talk about attack vectors such as insecure data storage, secret storage on device, cryptographic keys stored in clear text or transmitted into the open, weak server-side controls, input validation slacking on the server side, and the client application talks to the server, but the server doesn't perform enough authorization, authentication, and input validation checks on its input, etc., injection attacks, security decisions via untrusted inputs, such as unsigned, unhashed, or client-side inputs. So we have a lot of vulnerabilities in each and every application, and the main problem that we have that we are not part of the development team. When we perform black box testing, we are called out of scope. Usually we get no documentation. We get pre-allocated hours or time slack to perform the test and to submit a report. That's a normal procedure. And our main problem is we don't have enough time. If we had years or several years, we could sit with IDA Pro and reverse it, etc., but we don't have enough time to cover all of these attack vectors with efficient coverage. We need some help. Okay, so this graph highly represents the security assessor moods and agony during the test. If he finds something, then he's happy. If not, when he's effing the report, we are really bummed. Yeah, right. So, if we're talking about iOS black box assessing, there are two major technologies that we want to adopt into our means. This is static analysis and dynamic analysis. Static analysis tools are very well documented, using file access to the machine, using clutch to decrypt the fair play protection, using SSH into running commands that you shouldn't run on the jailbreak machine, IDA assembler, hex editor, plist, database, SQLite browser, etc., in order to try and enumerate as much information as you can in order to understand the application logic and the business logic and its constraints. Now, dynamic analysis tools are trying to do the same thing, only when the application is running. So we have our proxy setup, and we have a mallory setup to traverse the proxy to stream into our location. And we have Cycript and class.z in order to enumerate as much information in dynamic access. And HITB, maybe we even written or used a special hooking framework such as Theos or Logos, or such as Captain Hook, in order to re-implement pain point implementation in the application. So if we're having a look at the typical setup for a black box test, we see something that's similar to this location, to this specification. We have the mobile device. It sits around a mallory or other TCP rerouting scheme. We have our proxy or main attacker tool, maybe a scanner, and we have the application talk to the server endpoints via our interception and examination. Okay, this is nothing new. This is a normal setup. Now, the thing going on with iDevices and the current application is that this setup should allow me to perform a formal black box testing. But my main pain point is that I'm doing it black box. I don't know a lot of information about the application itself and about its logic. I'm not part of the development team, so I don't have access to code. And I don't have access to the simulator, right? I don't have an iPhone emulator. I have to perform the test on a real device, which means I can't take snapshots and revert to snapshots, etc., etc. It's a big headache for me. If I did something wrong in the middle of the test and I got the application remove or change its attributes, I don't have any way other but reinstall the application, redo all the flows to get to the same testing stage, right? So this is the real pain points, that we don't have any VM, etc., so we can snapshot and revert to it. The fair play is a bit tricky, but currently it's very available to decrypt with clutch or clutch mode or clutch patch. And we have a major black hole of information because we don't know what are the application really capable of. We are not part of the development team. We don't have access to code. We launch the application. We can see one screen or two screens, and we don't know what are the functionalities that it hide behind this screen and between these view controllers. Another thing that we are missing is the endpoints that this application is going to talk to. I set up a proxy, I started locking, I registered the user, I did a login, I tried to do injection attacks, etc., and I noticed that the application tries to access peers, several peers on the server side. At what stage do I know that I covered the entire peers that this application is capable of contact? I don't know, because it wasn't invoked yet. And I don't have any means to know the exact percentage coverage that my pen test is being performed. I'm in a big problem because I don't know. Did I cover all the fields? Did I cover all the functionality? Maybe there was an administrator functionality that's hidden for a specific pre-encoded user. Maybe there are several other functionalities that I'm unaware of because I didn't know how to trigger them on. I didn't know how to cover these areas. So, looking at the current status of black box iOS pen testing, it's not very promising. It's not like we're doing an Android penetration testing when I can take the code and reverse it and go into a higher level, which is Java, Dalvik, higher level code, and I can read it and I can understand it. At iOS, if I want to do a reversing, the only next step I get is ARM, right? I got ARM opcodes and bytecodes instructions. I need to go to assembly of ARM. And it's a very big and heavy task to go and do this for an entire application. It's a really tedious task. So the typical approach these days is to monitor the file system and monitor the network and monitor application invocation via CFURLs or external protocols, and to look at the binary and decrypt it and try to do some class identification using class tampz, and then run IDA Pro and attach to it with a GTB or other debugger, and try to mess around with dynamic messing around with it with Cycript. Okay, so if we're looking at a typical approach, the state of the art is doing a fully reversing of the binary. When you got the enough time, you got enough money spent, and you got enough knowledge, you can do a fully reversing of the entire binary. This is very good if you have the time. It's very good if you have the people to do it, if you have the knowledge to do it. That will cover a lot of information. But usually, you don't have enough time. And usually, you're in a very risky state. Eventually, you will get there. No, don't worry. But depends when, right? It could be several new iOS version before you even cover 20%. Another pain point that we have performing Blackbox pen testing is that current application developers, they know about proxies. They know about developer tools. They know about proxies. So when the application wants to communicate with the server or vice versa, the request is not going to be tamperable. You're going to implement some kind of a hash algorithm or an encryption. And if I'm interfacing with these kind of applications, that gives me a lot of headache. Because once the application enforces hash algorithms to the request, for example, mailbox, if I try to tamper with the parameters, if I try to load a payload for injection string, etc., the server is going to decline the request. It's not, you tampered with it. I don't want to eat it. It's fishy to me. And the same goes for encryption. So these days, application communication goes either signed or either encrypted, or even worse, binary. If I'm looking at this request through a proxy, I have no means to tamper with it. I can try to do a replay attack. I can try to do a patching attack. But usually I just corrupt the request, and it's down the drain. And usually current financial applications enforce both binary and hashing. And the hash is recalculated per session. So it changes every session, every time. So I need to invest a lot of time, a lot of effort in reversing binary of ARM opcodes, learning the algorithm of the hash or the encryption, trying to identify keys, and trying to reverse all of this logic only to fully be available to start manual testing with injection, right? So now I can calculate the hash, calculate the encryption, I can inject my payload, I can start playing around the application. Until now, I covered zero. I didn't do anything, right? So we get into the understanding that the old setup is no good for us. This old setup of putting the proxy in between the client and the server is very good for web application, but it's not good for iOS application. It's no good for new application. It's useless. We need to think about a new concept. And the new concept has come to my knowledge by introducing of Objective-C class interposing. Now, this is a small question for you. What should be the result of the running of this Objective-C code? Can you guess? That's a question. I'm not shooting anybody if it is wrong, right? We have an error message in a string, which is being initialized by an access denied string. So we should see that error message got the string. Well, surprise, surprise. In each and every of the following parameter invocation, parameter initialization, for each and every of these strings, can you turn a bit the light maybe, it's too. There are strings, access denied, get me a hacked account. If I init with hello, I get hacked account. If I init with what happened, the parameter is initialized with a hacked account. So what happened? What happened is I used the fundamental class interposing of Objective-C programming language into implementing a new functionality to the string with string selector. I use Cycript into defining a new message selector that for any invocation of init a string object with the following string, it will return hacked account. This way, each and every time the application is going to call this string with string selector, it's going to run my code. It's going to run my implementation. And there is a lot of power in holding such capabilities. Think about authentication scheme functions that says authenticate against user, return Boolean, yes or no. Is client authenticated? No. No, it's okay. Yes, return yes, okay, very nice. So by using this power, by using the Objective-C class interposing and Objective-C specific architecture, I can use it to my benefits. I can use it into rewriting the logic that came out of iTunes, out of the developer pushed to the store. Another example for the same idea. I have the proxy setup text box inside of the system preferences application. And you see that the port area is numbers only. I got the numbers keypad. What if I want to inject a string inside? I can possibly do it with the keypad, right? It's numbers only. It's blocked by design, right? The server on the end side doesn't expect to receive other input than numbers, right? What happens if I start and tamper with this value? Now, using Cycript, I can do that. I can attach to any binary running process and access its namespace and change whatever I want on the fly without recompiling, without repatching. It's a fully tampering environment for me as a hacker. So this concept is not known. It was known for Objective-C on OS X, and is known for iOS by Cycript. You can download from Cydia. It's Cycript tools, very good tool. So I'm sorry for the red, but you can see that with very little lines of code, with a language that is similar to JavaScript or to Objective-C syntax, I can change the label text from 8080 to Cycript was here. Okay? So I can override parameters, I can override methods, I can override functions, I can override whatever I want. And let the application do the tough thing for me. Let the application do the hash. I don't want to know what's a hash algorithm. I don't have time for that. I need to do a Blackbox pen test. I want the application to hash or 1 equalize 1 minus minus on the payload. I want the application to encrypt it. It knows the algorithm. I just need to know what is the right function, right? I just need to know where is the right selector. What is the right business logic that helps me tell Cycript to invoke this functionality. So if we're looking at this new approach, Blackbox testing using Cycript, then if I know the right protocol, I can really solve binary protocols problem. I can really solve signed request problem. I can solve it. I only need one key information that is missing. I need to know where is this object accessible? What is its name? What are its methods? Etc., etc. And this is why I developed the iNalyzer. The AppSec Analyzer is based on remote invocation of Cycript throughout a specific pen tester dashboard that's created for the specific application. It enumerates, like in the small Dropbox application, enumerates the entire information that can be retrieved from the binary on the device itself. It wraps it around into a zip package that you download to your PC. You run a small script that creates a dashboard, and you start pen testing using this Firefox web page, invoking Cycript commands on your mobile. So, how do you get iNalyzer? Well, it's free. You can download it right now from the Cydia repository. Go to our AppSec Lab Cydia repository and download it. And activating it, very simple. Just click on it, and you get a listener report on your iDevice. Once you got your listener report on your device, open the browser, any browser, and browse to your iDevice IP and the port that you got. Now, this is what it looks like. We have a drop-down menu. Let me show you a live demo. We have a drop-down menu that covers the entire application that are installed on that device. The device has to be jailbreak. We download from Cydia, okay? And with a click of a button, iNalyzer takes its actions and perform a snapshot and the static analysis of the binary to create a package for you to download, okay? 2 small steps are required to run iNalyzer successfully, and it's noted in the iNalyzer menu. You need to install Graphics and Oxygen, which are open source and documented and free to use, in order to unpack the iNalyzer package. So after we've done that, and we create a package for our binary, let's say Dropbox, we'll get a download link, which we'll extract into a selected folder, and then run this small Doxygen launching script. You can run it on Mac specifically by running it, or on Linux, or if you want to use the graph wizard, you can open the docs template file and run it. Now, dashboard building can take time because Doxygen is automatically going to link and connect the entire class hierarchy that we find inside of the iOS application file. And after it finishes, you will notice an HTML index.html subfolder inside of your unzip directory. And when you open up that HTML file, you're going to be very surprised. This guy is it's a very good starting point for any Blackbox and Dropbox, right? I got a full UI filled with information about the application, which I was unaware of. I can see each and every class that sits in the file that Dropbox uses. I can see each and every view controller that the application uses. With a simple click, I can force the application to load it and see what logic conveys inside of it. I can see the entire class hierarchy. Let's say I want to see okay, let's look at the Dropbox app delegate class, the main delegate application class. And I can see what are the functions that I can invoke on it. Each and every one of them is fully undisclosed into my hands without any effort. I could see things like redirect using URL parameter, and I could see a method that's called password view controller did receive correct password. That's interesting. Password did receive correct password, which takes parameter. Let's see if it works. What do you say? So I load up Dropbox with VNC, okay? And I'm gonna use the Cycript console on iNalyzer dashboard to communicate with the Dropbox that's currently running. We're doing dynamic analysis now, together with the static analysis information that we got. So I'm loading up the console, and I'm invoking now a standard Objective-C syntax, opcodes, and commands and selectors, such as UIApp for UI application, and delegate. And I receive a response. You're looking at a Dropbox app delegate, which is set as at the pointer OX, etc. Okay, I want to invoke on that element, on that Dropbox app delegate, I want to invoke the selector. So I'm using the Objective-C syntax. Passcode, view controller did receive correct passcode, and I'm giving the Boolean constant of yes, and I'm pressing go. And voila, Dropbox is just unfolded to me. This is purely dynamic analysis by using a prior knowledge. Did I have to work a lot to get this knowledge? No, it just simply runs iNalyzer. It automatically enumerates the entire connections and the entire hierarchy between the entire application. It does a bit more enumeration for me, such as I can look at the class collaboration. Warning, this is going to be a big graph, okay? And I can look for Dropbox app delegate is implementing a passcode background, is implementing a split view controller. We want to talk about it? You want to talk? To access this parameter, just click on it, see what's going on inside. Okay, I'll click on it. This is the public member functions. We have standard, and we have the parameters. We can access and change using class interposing and direct dynamic analysis Cycript. Okay, so now I have this whole page view of the information. Is that a better starting point for my black box testing? I ask you. And the answer is yes. This is a lot of information that will have cost me a lot of blood and pain to enumerate if I'm using ARM bytecode reversing. Now, using iNalyzer, I can see the entire flow of information that I couldn't see before. It's like someone sent me a documentation API about the application with me on the line. So, having said that, I can start to understand what iNalyzer can do for me. It gives me the entire hierarchy call graph. It lets me interactively communicate with the running application and tamper with it on the fly. Encrypt this parameter, decrypt this parameter, set user policy to admin, etc., etc. I'm using the application business logic and logic either to bypass server restrictions or to attack the server. I no longer need to put my proxy in between of the client and the server. So what should I use with my proxy? I already paid Burp $300 for the license, which shouldn't go to waste, right? Now, what I can do is I can use Burp or use my other scanner, Accunetix, AppScan, etc., web scanner, to truly fuzz and attack the server side. This time, standing behind the application and using iNalyzer Web 2 binary HTTP protocols to attack the server side. So I'm taking my AppScan or my Accunetix or my Burp intruder and put it right behind the application and chain them together. And then I can do something like this. Then I can do something like this. Under passcode view controller, there is a static public method that says password equals, which expects a password, which means Dropbox uses this method, uses this selector, to identify if the password is right or wrong. So let's try it. Password view controller. Password equals the string 1234. Tell me please, is it true or false? No, it's false. Okay, let's try 12345. Okay, no, etc., etc. But I can use Burp intruder to do this invocation, right? This is a web invocation with a simple get parameter. So let's run it through Burp, okay? I'm running it through my proxy. And I can see that the target is my iDevice in the iNalyzer listener port. And I highlight the position I want to payload, like in a simple web application pen test. We all done it thousands of times. It's very easy to do. The syntax here is the same syntax. I have the Objective-C opcodes that passcode view controller, please passcode equals and the parameter 1200. And I'm putting this through intruder. And by that means I get all the intruder logic and into asking the application, into using already known tools, already known and developed very good tools, into attacking the application logic or server logic that hides behind them, okay? So this is now attacking the application layer, using a web application tool. Think about SQL map, running on parameterized, hashed requests that you couldn't touch before. Think about running AppScan, or running Accunetix, or running whatever you want. All of your web tools, you can just port them inside. This is a simple GET request. And if the attack succeeded, I should probably see that one of these passwords gave me a result equalize 1, which means I know the correct password. So I'm interacting with the application layer using everyday web testing tools, right? And I could use it to shorten my time, no more manual attacks. I can I have a full list of the application logic and contents. I can see what is going on. I can invoke whatever I want on demand. I can even change my current tools to work on a new architecture, to work on an iOS device. I never dreamed it could be possible, but it's very easy, right? I don't have to change anything in the tool. I don't need to write new scripts or no twiggies. And using it is very straightforward, okay? So this is the demo we already seen. Okay, simple, everyday process. What else do I get from the iNalyzer dashboard? Okay, so it's create this special HTML file for the entire application, for that version. What else information does it do for me? What else information does it enumerate for me? So when I'm using the iNalyzer dashboard, it takes a look at the info plist file. And if you're a Blackbox tester or have some testing on an iOS application file, one of the important files for you to check and monitor is the info plist, because it holds a lot of invocation parameters, invocation schemes for the application itself. In this case, I can see that Dropbox has registered itself with a DB API -1 URI scheme, which means each and every time the iOS Springboard operating system is going to be introduced with that URL scheme, URI scheme, DB API -1 / whatever, it's going to let Dropbox do the parameter input and execution. This is a new entry point for me into the iOS application. This is a new fuzzing peer point for me into the iOS application. I can use Peach, I can use whatever fuzzer I want, because now it's a web protocol that is very, very common to use. Okay? What else can I find? Well, iNalyzer does a simple static analysis of string grips. So I can take a look at potential local string SQL injection, SQL injection in the application. I can see that the select data from data cache where key equalizes concatenated string, this could be a very good potential if it's exposed to user input or to web response input or to user invocation. So in this way, I can build myself a really good pen testing plan. I know the entire application view controllers. And view controllers are key elements in any application, because the application logic is divided by the view controllers. I have a login view controller, I have the sign out view controller, I have the do transaction view controller, and each view controller holds the entire logic and the entire business logic of methods to invocate upon this object. So I can now know, without paying anybody for doing a fully reversing, I can know the entire structure of the application, yes. I know now that if I was stuck on the login view controller scheme and the registration, that I have album picker controller and asset picker controller, etc., etc., etc. I have a lot of other aspects that I have to monitor. I have to keep in my leads list that I didn't know before. So using it is very simple, and assessing is very simple, which makes my life as a pen tester really easy. Same goes for static string scripts. Inside of a file, I can go into embedded strings and look at the entire strings that are embedded inside of the file, and I can see that the application wants to write to temp run.log file, which maybe I monitor it, maybe I didn't. Maybe it skipped under the radar. And if I dump it, I can see that I have the full developer logs written into that file. So if I want to summarize at this point, when I'm using the iNalyzer, I'm taking my everyday scanning tool, an everyday web testing tool, and I remove them from in between of the communication channel and porting it backwards to let the application do the effort for you. And then I'm messing around with the application. I can do it because I'm running on a jailbreak device. If I say that this Boolean field is going to hold a number and going to hold a SQL injection payload, it will do it because I'm root, and the application runs under mobile permissions. Cycript will force it to hold this parameter, to encrypt it, and to send it to server. Does the developer on the inside expect to receive something other than Boolean on this parameter? No, because it said no. No way. Requests are hashed, encrypted, salted, whatever, peppered, mayonnaise, whatever. There's no way I'm going to receive a SQL injection. Look, he's got a keypad. What's it going to do? Give him some slaps so it will change? With iNalyzer, I can. With iNalyzer, I could really beat up the application into doing what I want to do and not what the developer wants to do. So if that concept is understood, let's talk a bit about the background. What's going on inside the iNalyzer? Why is it so much easier to work with it? Well, iNalyzer is not a very big technology leap. All I did is combine together all the small Lego blocks that will respond for this functionality. So we have a jailbroken device, 5.11 or 6.2, thanks to Evader's team. And we have Clutch to decrypt the application, thanks to emulation. And we have class dump Z to dump the application classes, which is inside of the ARM macro file that OS X and iOS works by. That's in the fundamentals, you cannot change it. So now that I got all the header, hey, listen, I got this great tool, it's called Doxygen, which is take a header file, run it through that folder, and will generate a correlation and the hierarchy between those. Wow, wonderful, let's use it. And I'm using Doxygen into creating my pen testing environment by modifying some HTML files, that's it. I'm running Cycript on the mobile itself, so it communicates with Firefox web page, HTML page. And I just need to repeat steps 6 and 7 until the Blackbox is completed. If I really and truly want to do some advanced monitoring, I can monitor whatever is going on in the application using Subjective-C, which implements a new implementation using message functional interposing to the message Objective-C message sent selector, which is the main selector goes on any Objective-C application, thanks to Ken. So using these small tools, sharing them together to do something dynamic, I get a full list of benefits. I don't need to break my time. I had to spend a lot of time doing GTB and IDA reversing. I still need to do it for specific regions, but now I can select which. I can focus the reversing teams only on the selected areas that I don't need to do it manually. I have a semi-automatic static analysis, which I can expand because it's open source. You can use it, you can recompile it, you can do whatever you want with it. It's a free tool, you can use it. You should use it. I would use it. We have the automatic call graph generated for me. So now, if I want to use Cycript for hacking the application, I know each and every pinpoint action that I want to mess around with inside the application. And I can attach any common web-based tool into abusing the running application or abusing its server, which is more important for me. This is bypassing every business logic that was implemented into application. Well, what are the cons? It's free, so I don't get money on it. And it's open source, so I can't ban you if you mod it. And if that is nice, what about running it on any application, such as running it on a mailbox application? I don't want to stay in line. So let's set, I'm Israeli, you know, we like to cut into lines. We don't like to stay in line and sit quiet. Let's cut into lines and cut my waiting lines for the application approval for me to get inside, right? So I'm running it through there on that set places in line. Request, as you can see, is I've wrapped it with a small JavaScript function. It's called me. And by using it, yes, here is the whole recipe. Okay, starting with this function. Okay, I'm calling the overlay whatever selector, getting the current user object, taking this current user object and calling a setter. On that property that's called set place in line. On the received parameter W, this is JavaScript, right? This is Cycript power. And then return yes. And then I invoke it. So each and every invocation, what is happening is my web scanner, my web tool, is actually interactive with the iOS application, bypassing any business logic that's implemented inside the application, and thoroughly implement my attack on the server side. Okay? And this is what you see at the request as function me, that's the setting, equalize whatever you saw, and then I'm invoking me and 263.9407 for each and every row. So you can see the counter is going down. Eventually I got in. Very nice application, I must say, but the idea is very clear. So now that I have this power, and now that I have these functionalities, it's time for you to pitch in. And we'll try to do, with the time that is left, which is not a lot, we'll try to do a live demo of iNalyzer invocation. So bring it on. We go through the iNalyzer menu and select whatever applications you want, but not Hebrew, because Unicode is not fully implemented. Okay? So if you go through the menu, okay, we have AirP, wins, etc. Whatever, stop me where you want. This is an open demo. Not all together, because it's too much for me. I'm overwhelmed, I'm presenting, I'm stressed. What? What? Bank? Where? Don't get me into trouble. Visual Blitz? Okay, let's do Visual Blitz. Hopefully it won't crash. That's the problem with live demonstrations. Okay, let me start if we're doing a live demonstration. This is going to run for some time, but let me show how it looks on the device itself. This is the VNC connection device itself. What we have here is failure to What we have here is a small invocation toggle application. You just click on it. Try to load on port 5444. And I'm opening up my browser and communicating to that port. I will receive the iNalyzer menu, okay, with a drop down. I've already installed the application. And voila, the package is ready. 50% is off, okay? So let's unzip it together. Okay. And wait for it to download. Hey, you have a bag. Okay. And it's big. Thankfully, that means it didn't crash in the middle. And, okay, it downloaded. Let's put it in a folder, Blitz. Okay, really simple, no Unix, Kung Fu, whatever. And if I take a look at what I just unpacked, what Trojan is really telling me, I can see that what we did is take a snapshot of the application. Here's Blitz, okay? We have here the standard IAPP structure. We have reversing files, which hopefully, with God's will, is fooled. Didn't, okay, failed. It's a little bug, okay? And we have, this should be full with all the class files, okay? Direct class files. And this is a simple matter of running class dumz on the binary, decrypted binary. So we were invoking clutch decrypted binary. We're invoking class dumz on that decrypted binary to enumerate the files. It's really easy to fix, okay? And under docs, and I have this docs template, which is the run template, the footer, which holds all the JavaScript for the toggle on, toggle off mode. And we have the client files, which is a snapshot of the entire application for the client's as we did it. So we could investigate it thoroughly about local SQL and local databases and log files, etc., all on the machine. So it didn't work as I wanted, so we need to fix that. Let's try a different one. I'll go on to the application. This is the problem with lab demos. You work for the build, you publish the build, it's on CD repository, and then you got a space in your script. Didn't work, okay? Let's try another one, okay? Let's go into whatever. Facebook. Okay, hopefully. I'll embrace myself so it will work, okay? Let's see if I can check, because it just it twice, okay? So come on, Facebook now, the analyzer is invoking, eventually what's running under the screen is I'm running clutch, okay, to decrypt the application. Then I'm running OTool, then I'm running class NZ to retrieve from the decryptor application, retrieve the entire header files. And I'm doing a simple CP and zip for that files. So let's not wait, let's see if we can be more productive. This is just me doing live debugging on the analyzer, and we can see that class dumz is running, thank God. This demo didn't break, okay? And if it's finished, it could take some time because Facebook is a big application. Until it's finished, let me show you what goes on the device itself. Okay, so on the device itself, Analyzer is using the clutch source code, is doing its own modification and string analysis on graphing for strings. If you want to take the code and change it, you are very welcome, because it's very easy. Let's do grep. Okay. So, as you can see, it's even highlighted. Okay, this is the SQLi regular expression that I use to identify any insert, update, delete. You can modify it. You can do whatever you want with it. It should be outside, but this is a better release. Okay, and you can see that we are graphing for strings, right? And we can see that you are doing a plist on the info plist file. So these are all common techniques, common tools that are changed together into supplying you with the ultimate testing environment without too much fuss on your side, without too much effort on your side. Okay? If it runs, if it breaks, then recompile it and whatever. Okay? What else? Here is the class name there. Okay. No secrets. And I will take questions until Facebook will be so kind into downloading to my Trojan laptop. Yes, please. Not all together, just you're overwhelming me. Questions, yes. Nobody listening, it's not recorded, false, yes.
Is there anything the developer can do to prevent such an assessment?
Well, the only thing you can do, well, two things you can do. First thing you should do is obfuscation. Now, if you want a good pitch for a startup application, this is recorded, so you must hurry. A good pitch for a startup application is obfuscation on iPhone applications, because they're currently unavailable. Everything is get documented inside, even remarks. So obfuscation of iOS application would be a very good thing to do, but it has to be, mentally prepared for dealing with functions named A, B, C, A1, B1, B2, and then fighting together on an agile meeting team You told me 2 is here, you told me 4, so you told me true, it's your problem. No, it's not a very good thing to implement. It's not a very easy thing to implement, obfuscation. The next thing you can do is knowing that attacker is going to try to invoke all of these kinds of messages, you want a booby trapper. Like, let's say I have a finance application, bank of hack in the box, okay? And we have doing the analyzer. I see a screen name, transaction view controller. That's a screen controller. I want to see what's going on. And on that we have a transfer to dashes, account number dashes amount. Wow, that's it, guys. I don't need to work anymore, right? Let's call Cycript and invoke it. What I don't know is that the developer implemented in that code delete the entire application data, delete the entire database, or even better, tamper with it so it looks legitimate, but it's falsified by the server. And now you down the drain with the entire application, right? You don't know what's going on. What happens? I don't know. I get 200, okay? I get but eventually the server knows that you tampered with the application, so it only looks like you're doing something. Eventually you're not doing anything. That's booby trapping the application.
Also, does it only work for Firefox or other browsers?
You can take the code, and this is my my tweak that I use the local cookies, and Chrome doesn't support local cookies on HTTP only. So you could do on local folders. You could use it for any. You could switch it to HTML5 storage, and it will work like a charm.
Okay, thank you.
Okay, any more? This is a showstopper on Facebook.
Do you have actually fallback mechanisms to dump a file, since there are known counter file from being dumped using Clutch, because Clutch is already quite a while around, and there are applications which, when Clutch is attempted to be used?
Well, I'll give you the Israeli solution. This is not my problem. You know why? Because behind of my needs to decrypt the application, there are millions and millions of other developers, jailbreakers, crackers that are going to do the effort for you. So in the beginning there was Poet Crack TM, right? And then became Clutch, and then became Clutch Patch, and then the Clutch Mod, etc., etc. The only thing you need to do, to worry about, is invaders not releasing another jailbreak, because then you're no good, okay? But let the community work for you. It's not your problem, decrypting application. Messing around with fair play, okay, for security means or for evil means, is a total global problem for a lot of people. So just keep monitoring and praying and hoping, or implement yourself, because the idea of dumping and decrypting the application under the engine really drills down to the proper MAC port. If you know what I mean. If not, there's an excellent book by Jonathan something about the iOS into the Apple score. It's a very this kind of book which drills down to the kernel Mac ports and Mac functions that you can use to do whatever you want. So it really depends if you're a slacker or you need the tool and you want to pay at the hours to do it, so you can do it yourself. It is open source and documented, so you could probably take from the missing step and fulfill your problem. Yes. Yay! Yay! Facebook. I'm waiting for this to happen. Okay. So let's hope Facebook didn't. Anybody here from Facebook? This is a responsible disclosure. I'm responsibly disclosing that I'm going to unpack the package. Okay. So let's go again. Let's hope with God's will that it didn't break. And extraction. And if I'm looking at the Facebook app, oh, you see all the header files? That's what I wanted. Just some small input, nothing much. Just a small input for Doxygen to run properly. Now, Doxygen is a very heavy machine. Have you ever run AppScan? 10 times worse because it's not multi-threaded. You can implement multi-threaded doxygen if you want. It's open source. Okay, so that is done. Let's off this and make the screen a bit bigger. Okay, this is human list. And I'll go into my desktop, iNalyzer 6 and Facebook, right? Facebook, didn't finish unpacking, okay, come on. Okay. Well, it takes it some time. Go on, Schwartz. Huh? No? Yes? You chosen a small, who chose the Facebook? Please go outside. No. It's a small application. You should just choose something bigger. Why picking up the small guys? Like, go for a bank hack in the box. It's a, why? I didn't want because the first one didn't work. I don't want to jinx it. Okay, so hopefully, okay, we have Facebook. Let's go into Facebook and then go to payload and go into payload for Doxygen. Okay, simple, common. If I look at Doxygen file, I have 3 minutes, okay? Docs me, okay? It simply invokes Doxygen on the template. So if you're on Windows user, just open up Doxygen wizard and load the docset template, or just create your own batch file. Okay, someone in docs.me. And this is Doxygen, this is not me. Nothing I did. This is the Doxygen regular execution when it finds all the proper settings. So it now goes through the reversing files, which inside I have all of the header files and the string dump and the string dump file that I created. And it will take it some time because it's a big application, and hopefully we have several minutes to. How am I doing with the time? With numbers or with dollars? I can deal with that also. And this is running and creating, and Doxygen will eventually create the UI for me. So I will have, when this ends, a coffee break afterwards. We will have a fully functional analyzer dashboard for Facebook, which includes the entire class hierarchy and implementation code. Any more questions while we're waiting for Facebook to finish? Yep. I'm sorry, I didn't. Yes. Yeah. You don't have Java code, right? Well, this is nothing new. This is simply Doxygen, which you're probably unaware of, which is fully implemented into corporations, into cooperatives, to document whatever API that just was shipped through space and know what's going on, run Doxygen on it. And okay, I can live with that. I have graphs, I have parameters, I have functions. So you can write it all yourself. If you look in Google, press Doxygen or created by Doxygen, you got more than 100 million results. So it's pretty known or known tools in the developer's side, which we are importing to our benefits on the attacker side. Any more questions? Ah, yes, we're going there. It's like Flintstones running through. Yeah, okay. So, any more questions, guys? This is going to keep on running until either they stop me or don't stop me now. Don't stop me, yeah. And any more questions, guys? Yes.
Can I just give the microphone quickly? Sorry.
Okay.
Obviously, you've been using this for yourself probably for some time now.
Yes.
Can you share a tad on your own success rate? Things that you could find with iNalyzer and not before?
Well, the thing is, because developers are unaware of what's going on underneath. They're unaware of it. And working in agile development teams means that they say, okay, today we're going to do feature pitch. We're going to implement administrator access controls, or we did that last version, administrator remote wipe of the device. So the first thing, you should verify that you are in administrator mode, right? No, it's okay. We have the administration view controller, which is loaded, right? If it's loaded, then the user has been authorized as administrator. So we have local authorization bypassing and server-side authorization bypassing because they don't expect for you to mess around with the application to load testing functionalities, debug functionalities. There was a very interesting finding that we discovered on PhoneGap applications. You know PhoneGap framework? Well, for those of you who don't know or unaware, PhoneGap is some kind of a cross-platform develop once, distribute to many framework applications. Develop one time the code, and then you wrap it up for iOS, for Android, etc., etc. And if you take a look at Android market to see the permissions that PhoneGap application requires, it's like, I want to be God on your own device. If you want to, I don't know, play whatever, right? On iOS, the user doesn't have this choice, right? Either he installs it or not. If you were running on the current, if you're running on the current version of API, it will ask you or won't ask you if he wants to access your phone book or your SMS data, etc., etc. It doesn't really 100 bulletproof, safe, okay? So when analyzing the PhoneGap application, we discovered that PhoneGap comes out of the box with audio recording functionality. So yeah, audio recording functionality. Maybe until this will end, we'll find one. Okay? So using audio recording functionality on a financial application that was developed with PhoneGap is really, really risky. Now the developer doesn't know that this object exists in his code, but you can invoke it and remotely record clients, whatever. So this is really cutting to the practical implementation of the application. Well, this is going to take some time. If you have how many time I have?
Not sure how much we have left. I think we're over time a bit already. So.
Okay, so I'm going to let it run, and if you want to see the results, I will post it.
Okay.
I will post the HTML files for you to examine and have a look. And I want to encourage every one of you to go, wait a minute, I haven't finished the slide. Oh, you're going to kill me. What about my Slack slide? Yeah. What is he talking about? Where is the... And gone, crashed. Yep. Yes, no, maybe, black. Yes, okay. It's an old Mac, but it's my friend, so I don't bitch about it. 1, 2, 3, 4. Okay, so for summary, this is the slide. Summary. Now, black box testing got a little bit easier. We know where to stand, we know how to enumerate this time slack, and we know that we need some more information about how to perform pen testing on mobile applications. It's a bit different. And we're giving a 2-day hands-on training course at this Black Hat USA for both iOS and Android. And question we already covered. Thank you. And for those of you missing the reference slide, it will be published together, so you can drill yourself and to educate yourself. Thank you very much, guys.
Thanks for a great talk.